All right, ladies and gentlemen, hello and welcome back once again to the briefing room. Yours truly, Eric Kavanaugh here. What a show we have lined up for you today. First, I can't go through a show without promoting the world's first made for TV webinar series, Future Proof. Check your local listings. We're now in 15 markets, including Washington, D.C., New York, St. Louis, Atlanta, Silicon Valley, all kind of places. Check it out. We hope to see you there. And let's focus on today. What is semantic intelligence? A focus on meaning. This is going to be really interesting stuff, folks. So let's dive right in. Here are our speakers. We actually have an extra speaker that we just added last minute. Pere Michael Brul is joining the call as well. Yours truly, Suresh Srinivas, former co-founder of Hortonworks. Hello. Also was the head of data platform for a company called Uber. I think you've heard of those guys. They have lots and lots and lots of data, and they learned the hard way how to wrangle tremendous amounts of data, and that's how you got Collate and the Open Metadata project. And Sriharsha Chintatalapani is also here with us, co-founder as well. And of course, the inimitable Malcolm Chisholm is here. We're very excited to have him, metadata expert for years and years now. I've learned so much from this guy. It's so much fun talking to him and hearing from him. So let's dive right in. I keep trying to think of ways to describe what's happening in our industry, and I was reminded of when I did my thesis many, many years ago in college on English and philosophy, and I focused on a play by Edward Albee called The Zoo Story. It's a very interesting play, two-person play. And at one point in the play, the one character, Jerry, said something, this is kind of late in the play, that really blew my mind. He said, sometimes it is necessary to go a long distance out of the way in order to come back a short distance correctly. And I thought to myself, wow, like that's pretty deep. And on our last show with Collate, Suresh said something after the show that really struck me, considering he was a co-founder of Hortonworks, and they put tremendous amounts of effort into wrapping structure around big data. Of course, all that big data stuff, you remember how quickly that took off, Hadoop back in the day, clusters, really trying to understand what's happening at tremendous scale, and that's what they figured out at places like Hortonworks. Well, after the show last about a month ago, Suresh said something that blew my mind. He said, structured data is an implementation detail. And I thought to myself, wow, that's coming from someone who worked tirelessly for years to wrap structure around big data to be able to analyze it and get to the insights. And then when I come up with this particular slide here, don't lose the forest for the trees. Well, the forest is the meaning. That's the whole point. We came up with all these structures, data warehouses, OLAP cubes, ontologies, schemas. I'm old enough to remember schema on read. Everybody got all excited about schema on read, right? Turned out to be a little more difficult than they thought. Data lakes, data lake houses. These are all structures. They're important. Ontologies, pipelines, but they're not the point. The point is insight. The point is meaning. So I'm very excited to have these folks on the call today to talk about how they get all that done. And I always say, don't do it yourself. Bring in the big guns. With that, I'm going to stop sharing. I'll hand it over to the folks from Collate. Take it away.
Okay, so let me set some stage for what is semantic intelligence platform. At Collect, we are building semantic intelligence platform for data and AI initiatives. And just quick background on who we are. We are creators of Apache Hadoop and many other open source projects that made what big data is 10, 12 years ago. So we have created many open source projects. We have contributed to many open source projects. Now we have created open metadata on top of which we are building Collate as a platform. Now our vision is make data people and AI ready, and towards that we are building semantic intelligence platform that connects metadata to meaning and build trusted data for AI to use. If you see, last 10, 15 years, we have built many tools that provide context for data. You have data catalogs, observability platforms, data quality platforms. What we realized as AI became a powerful enabler within data, context is not alone, context alone is not sufficient, right? AI requires semantics, meaning, right? And so this is where today we have people ready data where people fill in the gaps, right, from the context and derive meaning out of it, right? to AI, where semantics becomes very important. And that is the people ready to AI ready data transition that we are seeing right now. Let's look at what this semantic intelligence looks like, right? So in open metadata, we have 120 plus connectors to various systems that you have in your data landscape, and every other day, new tools keep coming up. And with the power of open source community, we have built all these connectors, which computes this metadata graph, right? By connecting all the way from where your online transactional, databases all the way to your dashboards and machine learning models, the last mile where you consume all this data. And that's what this metadata layer is all about. It has technical metadata, business metadata, operational data quality related metadata, social aspects of the metadata, lineage, which is very critical, and then finally compliance, right? Using the data the right way. That's what we started open metadata with, and now we are transitioning it into with AI coming in a big way, we are adding semantics layers, right? So semantics layer is based off of RDF, all and other semantic technologies that already exist today. And there's a world of concepts that are out there with semantics. We want to overlay on top of this metadata, which provides just context, right? What is the structure of the data, where it is stored, things like that, to bringing meaning. And that meaning is brought in by connecting to this world of concepts that are already defined in many RDF vocabularies that are not only generic vocabulary but also industry specific, right? For pharmaceuticals, finance, you name it. There are so many semantic standards that are available. That business concept is what we are overlaying on top of metadata, right? And so the transition looks like this, right? From metadata, we are moving to meaning, and from mere visibility, understanding the data, right? And automation workflows to be able to infer, connect dots and reason about the data. And then from cataloging to contextual decisions, right? All towards, to enable transition from human driven to AI driven, right? Now, what is this enabling, right? In the marketplace, what we see is, human gives the direction, and then there are AI assistants and AI agents automating autonomously all of the work that, you manually do today. And then AI assistants with human in the loop, managing the data and getting insights from it, right? And that's how AI powered business value creation is happening. Now let's look at, is semantics just sufficient, right? With semantics, we are bringing in the meaning, right, to the data, but that is not sufficient, right? For AI, it should be able to discover reliably the right data to use, needs to understand the lineage aspects, and then the data it is going to use has to be trusted, for which data quality and observability becomes important. And then finally, when AI is using the data, it has to be compliant, right? For, all the governance related regulations. That's where on semantic metadata graph, we have built this unified experience in open metadata, right? That makes sure that, you have trusted data for AI. The thing that we are building on top of this open metadata in Collate is this Collate AI. I talked about AI assistants, and Ask Collate is our AI assistant, and we also have agentic AI that automates many of the things, right? Documentation, classification, adding data quality tests, right? And alerting on, observability failures and things like that, and fixing some of the issues, right? In an agentic way. That's what we have built in Collate AI. And we also enable your AI applications using AI SDK and MCP server, so that you can build for, within your own organizations, your own AI agents and AI assistants, right? So that's what we are enabling with Collate AI. And this we are enabling for all the different practitioners, bringing them together and help them collaborate, right? So that's what Collate on top of open metadata looks like. Now, finally, right, when we started building this control vocabulary for metadata, and started adapting semantic, technologies and W3C standards that are available out there, we realized that it should not be, vendor driven, vendor lock-in solution. It needs to be open, right? Open both in terms of open source and open standards. That's the reason why we built Open Metadata as an open source project with open standards. Both our control vocabulary for metadata and semantics, right, using RDF and all is completely open, available as open source and open standards. And we invested a lot into building this community, and we are super happy that it's the number one, metadata platform, semantic intelligence platform today, with 12,000 plus community members, more than 400 contributors that make all these connectors and semantics and unified experience possible. We also have 3,000 plus deployments, across many enterprises. And then constantly, we get feedback, and we are, it's kind of our superpower where, our users continuously provide feedback and make this project really, develop, as a high velocity, semantic intelligence platform. So enough of slides. I will hand it over to Pere and Harsha to show it, what, in reality, and not just slideware.
Hmm.
Over to you, Pere.
Yeah,
Yeah,
take
I'll
it
go.
away, guys. Go ahead. Yeah, go ahead.
All right. Thanks, Suresh. So to make this reality, what we do, right? So as part of Semantic Intelligence platform, we built 120 plus native connectors. These native connectors bring metadata all the way from your APIs, databases, your Kafka topic, your dashboard, your pipelines, including unstructured data from drives. So all of this data lives in Collate. So to bring metadata, not only we engage these new connectors, what we do is to build, the user can come here and select their favorite kind of data warehouse, for example, in this case, Snowflake, give it a meaningful name, fill up the details, and all they need to do is click next. For the interest of time, I'm not going to go through all of these details right now. We have few connectors already running. In this case, if I click the Redshift, it deployed 9 agents. There are metadata agents, there are Collate AI agents. One of the tough jobs for any company to kind of organize this information effectively is to document all the data that's coming through, understand which are the most useful data assets out of that, and moreover, add the data quality to all of these assets. So we make it at Collate really, really easy. Just deploy, add your connection, deploy all of your metadata agents, and Collate AI agents works in tandem. As we are bringing in metadata, Collate AI will observe, hey, how is this metadata is related to each other? Let's bring a knowledge graph and document it. Along with, as the profiler is running, we look at data quality agent and say that, hey, these are the most important tables that doesn't have any data quality angle to it. Let's go and add test to it. So by just giving the connection details and deploying this, essentially we are automating every aspect of data governance and bringing it forefront from all the different aspects of metadata that's coming through. So once we have this data, and we also connecting all of this assets, tables, relationships automatically for our customers and users. For example, there's a fact transactions table. It has a test domain, doesn't have owners or tier. If I go to the knowledge graph, it shows me how these tables and the databases and everything else related to each other. For example, there's a fact transition table that belongs to test domain. It has an e-commerce as a database and database schema. And if I add, for example, let's say if I add a tier 2 as a tag and refresh this page, now it also has tier 2 as a tag. So nobody's sitting there manually constructing your knowledge graphs. It's bringing all of these things together automatically for you. Now, this is about not just the technical metadata, it's a metadata relations to how every aspect within your team works together. Now, another foundational pieces that we add is the business concepts that you're going to bring it from your company institutional knowledge. For example, I have a churn rate. Not only the definition is there, but it also has related terms and there are relations calculated from churn. Churn rate is antonym for retention data. And you can construct this with different relationships, and you can add relationships that is more specific to your organizations, edit this relationship, and set this glossaries up. Once you have a glossaries set up like this, we also automatically construct an ontology explorer here. So what is this doing here is, let me kind of zoom in. It will show relationship between the business concept. Churn is part of customer journey. Churn is antonym for retention database. It's also from Net Promoter Score. So you have very nuanced relationship going from the business concepts itself. Now, once we have all of this knowledge graphs and ontologies configured for you, the Ask Collate will be able to kind of understand the relationship between all of this data and able to find the right data to the user's question. Let me ask a simple question such as, what is our customer data? Without a semantic understanding of your data, this is a huge amount of query that needs to span across your data infrastructure. What is the customer data? Is it in, let me ask a different question. It's my customer data. In this case, it will be able to show all of your data here from a customer 360. It's a data, it is owned by an aggregation customer. There's a customer 360 as a table, which is of tier 1 and gold certified and owned by customer team. So among an ocean of data, it's able to find the most relevant data that is addressing the user's important questions here, and not only giving you different tables, but actually populate the right tables to you. So once we have this data,
One thing to call out here is this is not name matching, right? This is matching
yeah,
to the business concepts, right? There's a business concept called customer. That customer business concept is connected to various things, right? What data exists, right? And that's how this is happening.
and as I'm going through my journey, I want to kind of understand. I found the right table. It gave me the right signal, as Suresh is pointing out. It's a tier 1 goal. It's owned by customer team. And that is the table that I want to kind of understand a little more. I can ask for more details about this. It will give me the nice structured UI, not just a simple markdown that we throw back in traditional chatbot. We want to bring the UI to the user where they're working and give the ability to kind of understand, not just keep asking questions and just go through the wall of text. Here it's showing me clearly which domain it belongs to, what tags, what business concepts it's using, and what is a kind of schema of it, what's the data quality looks like, what are the queries that being run against this particular customer 360, all the way to lineage and custom properties. So by just asking this question, I'm able to reduce my back and forth between hundreds of thousands of data assets, getting the right data assets, and getting a comprehensive understanding of what is this table is doing for me. Now, just jumping quickly into from this journey all the way to able to ask what is a customer lifetime value, which is my definition that is stored in my glossaries, how it is actually impacts. Now I'm actually not only talking to the metadata itself that I'm storing, but also the analytics part of this data itself. So just to kind of wrap it up, from bringing the metadata in, constructing the knowledge graph, able to understand different parts of your data infrastructure and answer the questions from the customers, and getting the details right where the customer is asking or the user is asking, with a nuanced understanding of your business concepts and the relationship between the tables, is what we are doing here through the Ask Collate. And Collate is building that foundational platform to make it available for the LLMs to be able to kind of make reasoning better and understanding of your data better. Now, once we have this, our customers and users are using effectively. They are kind of building data quality out of this, business glossaries, understanding questions like this, talking with the data, talking with the right data in the right context. Now they want to build applications, and they want to build agents of their own with the power of context in Collate. So with that, we built AI Studio and AI SDK. Our founding engineers will be demoing that next.
Awesome, thanks. Let me share the screen here. And actually, before diving into these AI Studio and the rest of the agents, I would like to double down on what Ask Collate can actually do for you here, because in the end, it's not just about, oh, I can find my right data, but it's also about exploiting these reasoning capabilities of the agents once they have all of this super rich landscape of relationships and semantics that we have in our platform. So in this case, I can try to figure out if some of these tables are actually serving my purpose here, but I can just give up and say, okay, I don't care about this. Really just give me the average revenue. I know that this data is somewhere in Redshift, that's in my warehouse, and I want you, Ask Collate, to figure that out for me. So in this case, what Ask Collate is going to do is, first of all, pick the right table. Second, not hallucinate, because if I'm talking about customer tier, that could mean a gazillion things for a gazillion people. I can make it up. Some other organization can make it up. The LLM in this case can make it up as well. So in this case, what we can do is say, okay, looks like we already have this customer tier metric somewhere defined in Collate. So Ask Collate can figure out, okay, let me just not invent things. I will base the structure, the answer that I'm going to give you on this metric, figure out the query. If it messes up in the way, that's completely fine. It will try to readjust itself until it can come back with this nice visualization, giving me all of the data so that I can continue picking up the thread. So as you can see with Ask Collate, we don't stop at the metadata layer. We don't stop in this case at the Collate layer. Since we already have all of these connections and all of these capabilities, we can interact with the actual data itself. So this, Ask Collate, would be this conversational AI companion that we have here. But as Harsh and Suresh were saying, we have other agents in the platform too that are helping us in, let's say, not starting a blank page, because it's very daunting. You connect your Redshift, you connect your Snowflake, you have dozens of thousands of data. How do you start actually making sense of all of it? So, okay, let's try to automate some of the tedious parts. Let's try to automate how are we going to generate the descriptions for this data so that the rest of my teams can figure that out. Let's try to automate how I figure out the criticality, the importance of some of these assets in there. So all of these agents that are already part on the platform, the documentation agent, the data quality creation agent, the tier agent, now in AI Studio, we're actually exposing its internals. So I can say, okay, let me try to understand a bit more how this documentation agent behaves. So I can come here and I can say, okay, this is its behavior, this is its personality. I see that there's a data steward that it's quote unquote trying to impersonate this agent. It's going to have certain responsibilities, certain expertise areas, and then I can figure out, okay, does this persona suit my needs or not for what I'm trying to achieve here with my documentation. The second important thing is kind of the abilities that we are going to give to the agents, right? In this case, I'm talking about an agent that will handle documentation. So at least what it needs is the capability to fetch the details of some entities and either suggest descriptions or directly go ahead and apply them. So as we can see here, it has the metadata management capability, and finally, the actual prompt that this agent is going to do. So whenever this is going to be executed, it's going to say, okay, this is my task, those are my requirements. And maybe at some point we said, hey, we are in a Spanish company. I really want to make sure that this agent is going to generate these descriptions in Spanish. That's great. But then let's imagine, it's too lengthy. I don't want to read that much. Just try to make them shorter. So I can come, I can edit, make sure they are concise. Right? I can save the new prompt of my agent so that the next time that this application is going to be executed, this new prompt is going to be taking effect. Now, with AI Studio, not only we are basically giving visibility or transparency in the agents that we have in the platform, we are also going to give Collate users the ability to create their own custom agents. And this is going to be super, super powerful because in the end, it's saying, okay, how do we bridge these knowledge gaps that LLM have when we are trying to create these agentic applications? So in this case, we can use the Collate agents in order to solve these use cases for us. So I can click here on new agent, give it a name, certain description that matches what this agent is going to do. I can choose the persona. We give a few personas out of the box. You can create your own persona as well. There's fully customization in there. In this case, I'm going to just assume that I need a data engineer solving certain tasks, maybe some impact analysis that I need to figure out. And here I can pick and choose the abilities that this agent is going to have. Maybe I need this to be able to track lineage if I'm talking about impact analysis. I might not care too much in this case about data quality, but I do need the agent to be able to discover and figure out the rest of the metadata, the rest of the assets that we have in the platform. Once I'm happy with the tools that I'm giving to this agent, I can pass it a default prompt whenever this agent is going to be executed. We can also change this prompt later on. I'm going to show you how to do that. And the last part is selecting this bot. And this is actually a super important part from a security and enterprise readiness perspective, because in the end, these agents are going to be interacting with Collate as a platform, right? And they have all of these tools, all of these capabilities that I'm giving it, but I'm also able to say, okay, there's going to be this bot, this service account that it's going to be impersonating this agent, and I might want to give only certain permissions to this bot. And I can say, okay, maybe this impact analysis agent should only work on the marketing domain, or should not ever be able to edit metadata, only be able to read metadata. So the same super rich RBAC permissions based on the rules and policies that we have in the platform that you can give to users, you can also give that to your agents as well. Now, the final piece to this equation is how do we actually interact with this agent? And this is where the AI SDK enters the picture, because as Harsha was saying, at this day and age, not everything is about REST APIs, right? We started with these JSONs, everything, how these different services were communicating was with this structured language. But at this point, we are past that. We have the LLMs, we have the capabilities to create all of our applications based on natural language. And since we have been hearing more and more from the community and from our Collate customers saying, hey, I'm actually starting to build and productionize all of these systems that are based on the semantics and this intelligence that Collate have. The point of the AI Studio is to help people streamline all of this. So as you can see, with just a few lines of code, I can connect to my Collate instance. And in this case, I can ask my data quality planner agent, what do we do when some tests are failing? I don't need to figure out my REST APIs. I don't need to figure out absolutely anything. I have an agent. It has some capabilities. Let me directly chat to it. So
it is sort of like, having your colleagues that specialize in certain skills, and then you can work with them.
Correct. Then this really opens a box of very, very, very cool things that we can do without actually having to care about how do I manage my provider and the agent security and the actual orchestration system in my agents, because Collate and AI Studio is going to take care of all of that. Instead, I can keep my eyes on the prize and say, okay, what's important for my company? What's basically a huge problem that we have today? Maybe this problem can be GDPR compliance, because there's more and more people that it's knocking on our door, at least in Europe, and saying, hey, there's someone called Michael that it's saying, I want to be forgotten. Just delete absolutely everything that I have. So I can create all of these applications that are going to help my workforce to start streamlining and automating all of these tasks, because in the end, GDPR, it's not an easy problem to solve, right? In this case, my agent is going to tell me, okay, there's a ton of assets that are being impacted. You have all of this list of tables. They have different retention periods. They have different levels of API. There's also maybe conflicts, because how we defined maybe just a few months or a few years ago, our retention policies are actually impacting this new GDPR compliance that we need to follow. So this agent can actually figure this out and say, hey, looks like the analytics table says that the data needs to be there for 5 years, but there's another table downstream that says the data should be only for 90 days. Like, how do we make sense of all of these issues? Or how do we make sense on the right deletion order? Because there's going to be all of these foreign keys, all of these downstream transformations that are going to happen. How do I make sure that I'm tackling this problem in the right way? And at this point, we're not even talking about having or not a data catalog, because if we would still have a traditional data catalog, this data would be there. I can search for my tables, I can pick up my constraints, I can figure out my lineage, but it would require a team that knows what they are doing, that can understand the data, that can pull all of the hours and all of the effort to actually make sense of all of this information. Instead, if we start pulling AI agents inside of this equation, we still need the experts. They need to validate if this is the right approach or not. But I can go from a bunch of hours of just hitting myself in front of my lineage graph into just giving a first approach on, hey, this is my suggestion. That's how you can actually go around this problem. Now you review it. You push forward however you need, but you are saving a ton of hours in the process. And that's how the AI Studio, that's how this AI SDK is actually hopefully going to help everyone innovate, automate, solve all of these hard problems already there so they can focus on the rest of things that make more sense for their business.
Wow.
So yeah, back to you, folks.
That was pretty impressive. All right, Malcolm Chisholm, you're up, my friend.
Thank you very much, Eric. Let's get to it. So let me get this into display mode. Come on. So just some preliminary thoughts about where I'm coming from when it comes to intelligence, meaning, metadata, and so on. What is metadata? It's often said to be data about data, which is like, don't say that. I think it's the data that describes all aspects of an enterprise's information assets, enables the enterprise to effectively use and manage those assets. Now, it's not necessarily a new concept. So Dr. Samuel Johnson, who wrote the first commonly used English dictionary, said knowledge is of two kinds. We know a subject ourselves, or we know where we can find information upon it. So the idea of metadata is something that's not necessarily modern, even though the term may be. And I think we need to think about that because there's an infinite chain in terms of what you consider metadata. I might actually consider data, and then I have data about that, which is more metadata. And the American pragmatist philosopher C.S. Peirce kind of showed this chain has no end. One symbol is getting changed into another by an interpretant. We don't need to go there, but we just need to think about what we are trying to do, which I think the colleagues from Collate have shown pretty effectively. So that's super important. The next thing is there's many different kinds of metadata. So I've struggled with this over the years. Here's my thoughts on what I call a metadata subject area model. The term subject area has been replaced by the word domain today. Apparently the word domain can have not enough uses. It's used for pretty much anything. But this is like thinking about, okay, we take that idea of metadata, and dig into it. What do we find? And I think that's what's exciting about the open metadata project, is that we can get some common agreement on different kinds of metadata that are out there and think about what's in them. And the other thing is it's changing. If you think about what's happened recently, we've got things are popping up now like LLMs.txt, which is like robots.txt, which now describes your agentic friendly website for agents and what they can do or not do with it. So the realm of metadata is expanding quite a lot. And just even the metadata around agents, or would that be metadata? I don't know. That also is something that's important. And I think another particular pet peeve of mine is metadata master management. So if you think about agents as being described by metadata or metadata entities, those metadata entities themselves have the classic issues of master data, like identity management, deduplication, things like that. So that also layers into this. It's quite complicated and a challenge. Some of the problems that I've seen. So definitions are not understood well and not done well. That's why I wrote this book a few years back on how to do definitions, particularly for information management. so that we can get good definitions. So, but that quality gap, I think, is still out there. So that's something that continues to interest me. The second one, which I think is being addressed in this in what we've just seen, is there's been a lot of complaints over the years by people that metadata is too fragmented. I have a federated metadata architecture, but that it's really fragmented. So I've got I've got a business rule. I need to know what the business terms are that exist in that business rule in its declarative form, which the user will or the business user will understand. But it has to relate to a data dictionary, and it has to run in an executable form, which is going to involve things like data quality, data issue or data quality issue management resolution, which have its own tools. So again, I think the idea that you have to have these connectors that will help span this is something that's good. But that problem, I think, is a complex one. So how do you practically unify the different metadata for automation and business needs is something that absolutely has to be addressed. So that's again super interesting. Another approach, which I think I've done and I've seen more in recent years, is to try to build a metadata lakehouse, which is to integrate metadata from all these different places that many of which are actually managing metadata, and then have back and forth between them to try and figure out, a sort of integrated view of metadata, but also solve the problem of a historical viewpoint on metadata, because metadata changes. So you can think of how many columns did we have in this table last year? How many do we have this year? Or any other kind of thing that requires the typical, slowly changing dimension type 2 issues that we see in regular data warehouses. So the historical aspect of metadata is also something important. So I think we need to think a bit about that too. And then it's changing. Again, we've got agent metadata, LLMs.txt that I've just described. We've got, a lot of semantic and knowledge graph metadata. And I think what we've just seen is really important, because automation is the only way we're going to deal with this. We can't have armies of humans do this. It's just impossible. The scale's too much, the complexity is too much, the velocity is too much. I mean, yes, you could try to get a human to document a database, but it's going to change. And how do you deal with that? We just don't have the human work power to do this. So automation is absolutely essential. It's the only way we can go forward with that. So that was, some quick thoughts on a general background. And so I do have a few questions for our colleagues, if I may, then, Eric.
Go ahead. That was good stuff,
Okay.
by the way. Metadata changes. That's right.
Oh, yeah, it does.
We need automation. We need the agents, but the agents need context and they need guardrails. We just saw the story the other day of Amazon going down, apparently because of an agent gone wild. I'm writing an article, AI agents gone wild. But go ahead.
Well, I think that's part of actually, well, let's go there. I will go there. So if you think about an agent, does it have a soul? And it doesn't have a soul, but it has something that's a facsimile of it, which is its system prompt, which Pere was showing us. So I think we have to ask ourselves, how are these agents being governed? So the worry is we're just going to get techies write the system prompts and say, you're an assistant, you're this, you're that. And without, okay, that's fine. This is like the kind of early days of big data in some ways, that it was ungoverned. Well, what are we doing about governance of our agents so that if we as an enterprise have principles, are those absolutes reflected in every system prompt for every agent that's out there? And if we're telling the agent to do something, do we ourselves have the definitions around what we're talking about so the agent doesn't pick him up from Wikipedia or something, or what it's been trained on. So I'll start with that. So love to get some perspective on that, because I think that's turning into something that's important.
No, it's super important. The issue that you are bringing up. So there are a couple of aspects to this, right? One is what can an AI agent do or not do? What it can access, right? The second question is on behalf of whom, right? It is doing the work, right? These are two important aspects for us. Now you saw in our AI studio, agents have a kind of a persona. That's a guideline on, yeah, the persona is a data engineer. He needs some aspects of the semantic metadata graph, right? On, observability aspects, maybe data quality aspects. You have, say a data citizen, right? For him, it's about what is curated data asset, right? What can be used or not, and that kind of stuff, right? So it starts with the persona, and then persona gives you a guideline on what it can access in terms of metadata and data, right? And then the second thing is for agents, right? Agents are working autonomously or independently, on a regular basis, automating many of the tasks. They are not working on behalf of a user. They are working to, automate certain things, right? For your data management, right? So those take this the permissions, right, what it can access, what it can do or what it cannot do, and you put guardrail around what an agent can do. Now in case of AI assistants where it's human in the loop and human is the one that is getting assisted, right, the as an example, I give this example always, right? So where you have an assistant and you say, hey, give me top 10 salaries within my company, right? You may not have access to that kind of data. If you end up building, so let's look at ChatGPT, right? ChatGPT has sucked in all this data from the entire web and books and all kinds of places. It doesn't care about who is asking the question, right? Other than some guardrails that they have put in where you cannot do illegal things, right? The entire information is available through ChatGPT to you. But when you start building assistants within an enterprise, it needs to know who is the person who is asking the question, whether that information is available to him or not, and then put guardrails around that data, right? And so in case of AI assistants, we also take the person who is using the AI assistants, his credentials, right, his permissions to answer the questions. But it's going to be very interesting, right? We also have AI SDK, right? We have MCP, and now MCP can be used by Claude or some other conversational agents, and you can use AI SDK for other agents. We have built-in guardrails where when you use AI SDK, you can use a specific agent, right? You can use a specific persona, and bind it to the specific kind of permissions it has. But it's going to be very interesting when people start using MCP and things like that.
Well, let me go there too, because I think MCP is super interesting. If you think, okay, so MCP allows AI to talk to other AIs or to APIs or to the data. Okay, now if you put an MCP server on, let's say conceptually something simple like a SQL statement, okay, the MCP server has to describe the data to the AI agent in English. So this is micro prompting within the MCP. And I don't think people are understanding that, but it seems that what you have at Collate could really help with this, because here's a table, it's like customer table, okay, and then what's the data universe of that? Okay, so US and Canadian customers. Anything odd about it in terms, well, yeah, we only have customers since 2016. And here's the first field and blah, 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 all of this kind of stuff. And there's this kind of customer, that kind of, so all this needs to be explained. Otherwise, AI doesn't really know what to do with the data. And is that something you see where Collate could help?
Yeah. So, you know, you're asking some questions related to customers. Which table to use, right? And for that, we have concept of tiering. Semantically, we have described it. But when you're, let's say, going through Claude, right, a generic, a conversational agent or AI assistant, it not, even if it understands some of these aspects, it should say, hey, you know what? There's so many customer tables, pick the right one, right? Those kind of guardrails we are building in our AI, right? Where, we have prompt engineering, all of those things that are done. And that's where I think that, a plain just go use the MCP tools and resources available and try to answer the questions, right? Understanding users' intent, but mapping it back to how the data is organized, what to use, what should be allowed, what should not be allowed. These things have to become prompt engineering on top of, some of the things that you're doing. Those are the prompts that we have built because we understand the semantics of data that we have stored. Now we can start describing how to do it, right, using the information that we have in our semantic graph. I don't know, Arsha, if you want to add more information here.
Yeah, so I think from my point of view, right, so MCP gave a lot of capabilities into Claude and all other VMs to be able to talk to any service that is out there without the needing to build any bridges. That's great to maybe, you go from 0 to 50, 60%, depending on who you ask. But as you're using all of this data and all of these services together, let's say you connect to Snowflake today through the MCP, my team has 10,000 tables. And every day I see people duplicating the data because they want to run some models, they want to run some tests. I can't prevent that. I actually want that to happen because they can do self-service. They are free to do all these experiments. But that tables in the view scope of the model itself. Now, model gets confused. It can't tell Harsha created this random table. It doesn't have all the data that I need, what the user is asking. It found a new table, someone inserted new rows. I'm going to go query that. Now, I have my business analyst completely unaware of how the data is stored. What happens in the data will get completely confused with the data that comes in. We often give, this is not a new problem. It's exploded into a new problem because previously, we gave this example from our previous life, which is in Uber, we underreported number of trips taken because someone looked at the wrong table. Now it's happening at much more rapid rate. Your LLM's looking at all the random data. Now, how do you bring the structure to it? That's where we come into play with all the semantics that we are bringing in. If I'm talking about customer lifetime value, it has to be agreed upon the experts within my organization across the board. Now that accelerate in productivity among hundreds of business analysts who are looking at it, my CEOs, my executive looking at it. That's grounded in truth, which is LLM give me the data instead of writing the query and going to the dashboards. But the context of it, the semantics of it is grounded among a agreed upon team members so that I'm making everyone productive, but it's in reality, not in, here is the vast data lake, you go figure it out.
Great, thanks. Thinking also about something that was shown to us by Pere, the DSAR, which is the data subject access request from GDPR, and there's several different kinds. This one was a delete. Thinking about that as an example, how do you see the agent fitting into an overall workflow? Because thinking about, I could say, oh, please find Pere's personal information and delete it. And I'd send this request in like, nefariously, me, Malcolm, and I'm not Pere. So there's the idea, I think, better maybe put in terms of the CCPA kind of thing, which is they call it a verified consumer. You have to verify the request. You can't just have an agent act on it because I could be doing something bad with, trying to delete Pere out there. So there's a bigger workflow. How do you see that kind of workflow being generated and the orchestration around that, and maybe the humans in it, and that's the kind of overall AI product? And the agent, yes, it's part of it, and it's an important part of that, but that's part of it. How do you see that kind of happening?
Yes, I can go a little bit on that. So that's a classic case of your escalator privileges, right? And I think everyone kind of aware of recent what happened with OpenCloud deleting all the emails, going on that route. So what we do foundationally is even before without agents, and that follows our security model everywhere, we're giving the identity of the user itself who's asking this. So if Malcolm is asking, the AI agent will not get privileges higher than what Malcolm can do. So if you do not have access to that data, the agent itself will fail.
Yeah.
As in, I do not have access to data. Now, that's one part of it. Now, let's say I accidentally misquoted or misrepresented what the agent's supposed to do. I have an access to this report, but I said, go ahead and delete it. There also, we put workflows in place, approval workflows. When it finds the report, it will generate and wait for the human to come in and say that, hey, do you want to proceed with this? Right? Often I want to kind of double check it, and either don't want to kind of build this entire pipeline myself, but at least I want input before it goes and does anything destructive. So we go through the security mechanisms of the user who's asking it and bringing the workflows, approval workflows into the fold so that it doesn't do something accidentally destructive.
And Malcolm, when we implemented our first MCP server, we had built in, right, the authorization token of the user that will be used in those MCP calls, right? Which means it's the user's privilege, right, that, puts the guardrails.
Right. Got it. One of the use cases that I think is very valuable, which you kind of touched on it in the demo, is the idea going way back to the days of data administration in the 1990s, which is like finding tables that aren't used. They're duplicates. They're just, or columns even within tables. And in the current context of cloud costs with storage and compute, this kind of constant pruning would seem to be something where you could actually get a direct metric in terms of cost savings. So is that something that Collate can help with, to do that identification? Yes, even if I wouldn't want the agent to necessarily go and do it. We would like a human to do it, and the humans can take credit. But is that something that you can help with?
Yeah, so we were talking about metadata and all kinds of different metadata we collect. One of the metadata we collect is also operational metadata, where we have what queries are running, how frequently they are running, when some data is last used. And through queries, we also know what columns are being used, right? And so, today we have a report. We actually give you complete data insights on how what data you have, how it is being used, and we also give you unused data that you can take a look at it. And then, you can say, we also look at, because we are looking at your queries, we can also tell you these queries are inefficient, right? You can make it more efficient. So we have this automation that is already available, right? So where it suggests that this data can be deleted. Where we have not gone to is automate the data deletion, right? And what it would look like is, we feel that some automations can be trusted and automatically done, and some automations will actually ask you permission. It will say, hey, I have found this data unused, so much money is being wasted on storage, would you like to delete it, right? And even there, right, you actually would probably delete it in a way where, if accidentally something gets deleted, you can restore it within certain period of time, right? So those kind of guardrails need to be available. But yes, there are all these automations that can be made possible because you have complete context of metadata, right?
Yeah, I think that's very valuable. One of the things that's near and dear to my heart, because I wrote a book on it, is reference data, by which I mean code values. So if you think about financial instrument type equals equity or equals bond or equals derivative, what do those things mean? Now, those are not like columns or tables where the columns and tables have definition at design time. These things can be added. You can have a table, you just add something and give it a definition. Typically, those definitions aren't even in the tables, they're just names and codes. But yet that is metadata because it should have a definition. Is that something you guys deal with or see as an issue, or do you have any particular feelings on it?
Yeah, so the ontologies that we are building, this is where you can capture various concepts, and you can capture various different value types and all of that. And we consider this as conceptual, right? Semantic metadata. Now, once these concepts are defined, you can label your column, right, as this column is of this concept, and from that concept you can go on to different values, right, corresponding to those concepts and things like that. That's how we do it. And second thing that you're saying, in your presentation is some of this mapping today needs to be done in a manual, way, right? And that's where our semantic agent is going to actually look at your documentation, right? Your descriptions, your structured data, and then can come up with some core concepts, right? And those core concepts, many of these core concepts are already available, defined as some kind of a W3C standard or some RDF standard, right? We can start mapping it to them. And then, it's that becomes, 80% of semantic labeling, right? Overlay of the semantic concepts on your data that, human beings can take it to the next level.
Yeah. No, I think that would work. Yeah. Um, I was also kind of interested in that you could interact with the data. So I think you answered this already. Like if I was a business user and I'm not that adept with SQL, but you've seen the like common queries that run against the table I'm interested in, and will you help me like construct a SQL statement where I do a join of like customer to account or something like that? Because if I'm only an occasional SQL user and I mean, yeah, I guess I could ask, you know, to do that, but would you help me do that?
Yeah, definitely. So the right now in our demo, I think we briefly passed on is the ability to ask questions in a natural language. It will generate the query for you, not only generate the query, run the query for you, get the results, including analytics, which is drawing the charts and everything else. And what we have found in the recent benchmarks that we have done with the public data set, the public data set had 10% with LLM directly using the public set. With the power of semantic understanding we reached 54% accuracy in generation, just 44% increase in that. So
Wow.
just without customers doing anything, just bringing the metadata and using a powerful semantic engine behind it.
Right. Does that extend to usage patterns of the data? You can sort of look at those as well,
Exactly.
because again, you seem to be doing, you
Yeah.
understand what's running against it. Okay. Do you have any questions for me?
No, I'll leave it up to this. I do not have. It's been a great conversation. Yeah.
I'll chime in. I don't know if you guys have a hard stop or not. We can go a bit long if you want to. This is fascinating stuff. Here's one question I've got for you. You have many companies that have multiple data warehouses. They have Redshift, they have Teradata, maybe they have Snowflake, they're working with Databricks. I mean, it's interesting that there's this perception of a battle between Snowflake and Databricks when many companies use them both. So it's
Yeah.
like, all right, Databricks is the data science stuff, Snowflake's the data warehousing stuff typically. But what happens when there is a discrepancy in a definition? For example, customer lifetime value. In Snowflake, it's this. In Redshift, it's that. Teradata's got an older version. How do you reconcile that?
So that's where our metrics cataloging brings into the fore, right? So we centralize the metrics definitions into Collate itself under the governance. So it works in two ways. Right now, we're bringing any definitions that you are doing in Snowflake, dbt, Databricks into the foreground. And the users itself can propose, hey, this is our understanding of what is the customer lifetime value means, right? And there's a nuances to the metrics in itself, right? I think this is the example that I gave. If you go and ask what is a prospect means in a company like Collate, for example, marketing will say that anyone who clicked on the website, right? Sales team will say that anyone who I talked to today. And engineering product will say that, hey, anyone who started a POV with us. So it's a same concept, but different meaning. So you belong to different domain. And you cannot say that, hey, sales definition is wrong, marketing definition is wrong, and someone else's definition is right. It's their perspective of that. So that's where when we actually build a metrics can belong to the domain of within the company, which is sales, marketing, engineering, finance, and so on. So the definition might be, the name might be the same, the definition, the nuance can change. So if I, from a product, log in and say that, hey, show me the recent prospect number, it will understand that, hey, Harsha is looking for prospect, but his understanding of prospect and his expectation of the prospect is different. So I'm going to use the definition of that metric and query that and bring the data where it is. So
Wow.
this is the power of that, right?
Yeah.
So
I
Yeah, well,
also
this is,
think,
go ahead.
Eric, these kind of concepts need to be defined not in a local manner, right? One in Snowflake, one in, because when this concept evolves, you need to update multiple places. You don't even know where all these definitions are.
Right.
That's where I believe you need these business concepts to be defined at a layer above the implementation details, right? Just going
Mhm.
back to our
Right.
previous conversation. So that consistently you can apply it to Databricks, you can apply it to Snowflake, right? And that's where open metadata comes in, right? It's a layer that is sitting on top of all these different kinds of data, platforms, tooling that you have. You want to do it at a layer above.
Mm-hmm.
I think that's a fascinating insight because we've talked about that in the past, but nobody's had the appetite for it because they've seen data as passive and sort of documentation as why do it? But the problem now is that AI is driven by natural language, and the meaning, as we said at the very beginning, is like critical, and you've got to do it. So if you don't do it, it's not a technology thing necessarily, simply or wholly a technology thing with AI. You've got to go do that. And so you've had all of these sort of, you know, um, environments where somebody done something which was really oriented for a particular perspective or need, and you're not thinking about, or people haven't thought correctly. Um, it's not necessarily wrong as Harsha has said, but you have to somehow unify these things in a much in a broader enterprise context. That now is critical.
Mm-hmm.
Totally agree. The other problem that I also see is as conversational interfaces become available, right? People start with the question and query the backend databases again and again and again. It becomes brute force, right? Like everybody starts from zero. There's so much work that has happened in building dashboard and stuff like that. That's another thing that we are focusing on, right? You're asking certain questions, and then you're like, hey, turn this into a dashboard, run it, daily, ETL. And so there's so many dashboards that will get created, right? And so that's where understanding through the metadata what you already have, and when people ask these questions, we should, be able to tell them, hey, there's a dashboard that already exists, right, for this,
Yeah.
right? Here is this, right? Would you like to use it? That becomes very important. Otherwise, when making building things becomes easier, people will end up building and everything. There's so much queries that will go to your databases, and there are so many daily pipelines that are running. It just is going to be really a data management nightmare, right? And so mapping it back to here is what already exists to answer your question is going to be very important.
Mm. Yeah, well,
Yeah, I think.
go ahead. Go ahead, Malcolm.
Well, I mean, we talk about slop and things like that, which seems
Yeah,
to be
yeah.
the word at the moment. But it is very easy, but that puts a greater responsibility on whoever is doing the creation. Again, it comes back to governance. I think we can't just have things done. I don't know quite how we're going to solve that problem, but it's got to be something that has to be addressed.
Hmm. Yeah, we have one specific question from the audience, and I've got a broader question. One member is asking, thanks. So if I understand well, you're using RDF lib to map any semantic web language. Is that correct?
yeah, I don't think it's mapping up that, right? So for example, when we are defining the specifications in metadata, we went with JSON schema RDF. We brought in the concepts of different, from all the way from semantic web to DCAT, which kind of does good amount of defined work for data cataloging and everything else. Then we brought in our own expertise of how these things should be laid out, like what does database has table means, should be contains. So all of those relations are built in for the RDF. It's not necessarily going all the way back to semantic web. Some parts of semantic,
I
some
see.
parts of DCAT, and DCAT actually doesn't do a good job in the sense that it says data set. Everything is a data set for them. If you have a file, if you have a table, if you have a dashboard, that's okay, but you want to be more nuanced when you say, what is a customer? I mean, is it a dashboard? Is it a table? Is it a file? So we brought in a lot more nuances to it. We built these standards and specifications to actually go very deep into the data itself. So it has very accurate types, shackle validations, and how to store the metadata and everything else, and what relations it exists. That's one part of it. That's your metadata and everything else. Then the business concepts itself. Business concepts is up to you as an organization. We cannot define what is an ARR and how do you calculate ARR for each company, right? What influences it. So we gave the power to the users itself and the customers itself to define those relations. And then you can upload saying that, hey, ARR is calculated from, ARR is derived from, that calculated from, derived from relations. You can create your own RDF specifications right within the Collate through the UI, saying that this is the RDF attribute I'm going to use for this relation, and I'm going to use that between these two concepts.
Yeah, when I think about AI, it's almost like a floodlight that's just been shown now on all of your data and all of your systems. And if you don't understand your workflows, your governance policies, all these different things, it's like, lifting up the rug after 20 years. You're like, whoa, what's underneath there? It's not very pleasant. And we talk about getting your data house in order. This is a mandate that I've been talking ever since the first day the LLMs came out. Because I'm a data guy, I was like, it's time. Like it's final exam time. You've got to get this solved. And this is how you do it, right? Because you can pull from any of these different systems and data, all sorts of different databases. And as you suggest, Suresh, it's in a layer above. So, we always joke that in IT, we think that one more layer of abstraction will solve all problems. And this might be the one. But what do you think, Suresh?
Well, as Harsha was saying, right? So, um, one, we are building our metadata itself using RDF ontologies, OWL, and things like that, right? So the metadata vocabulary itself becomes, ontology driven. The second thing is business concepts, right, coming through ontology, and that's where we have built this layer where, there are a lot of ontologies that are defined in many different industry segments, especially some segments are fairly tight on defining this semantic ontologies. So you can use your you know existing semantic ontologies. You can continue to build using Collate these ontologies for yourself. What I would say is this ontology should be derived from the standard ontologies. As an example, Harsha was saying for our metadata ontology, we have table as a concept, right? That table is a subclass of a data asset, right? And so now you have all these relationships, and through these relationships, now you can say how many data sets I have in my organization. It knows that table is a data set and Kafka topic is a data set, all kinds of things, right? So now it can actually do this inference through this logical relationship. Similarly for business concepts, right? ARR, right? What is my ARR, right? Okay, there's then sales ARR, then there is marketing ARR. Maybe different domains have different ARRs, but they are all mapped to some core concept of ARR, right? This kind of relationships can be built.
Hmm. Well, and the other thing that I've thought about for years, and maybe Malcolm, I'd like your thoughts on this, is that we have all these different pipelines, all these different ETL scripts. I mean, I remember asking 10 years ago, like, do you guys have a strategic view into all the ETL? And because maybe you're moving the same data multiple times in different ways and overwriting data and all this stuff, and everyone like scratched their head, looked at me and go, what are you talking about?
Yeah,
No,
and
we
I
don't
think
have that.
it got worse with the idea of data pipelines because they're not, they're isolated things.
Right.
So um, the I think that, again, if you think about it, that's metadata, and to the extent we can, again, humans couldn't go across all of that and figure out the overall picture of the giant spider web of all this stuff,
Right. Right.
but AI can. So I think that is super important, and it could go further than that and suggest rationalization. Again, I
Right.
think all of these data governance problems, they lacked automation in the past to be able to solve them. But now we have that. Now people have to figure out how to take advantage of that and how to actually do it, because it can't be business as usual anymore. And
Right.
Eric, I am going to have to bail. I am sorry, guys. I have a
No
medical
worries.
appointment. I got to go to it. Okay.
Malcolm, before you drop off, where can we find your book? It's on
On
Amazon.
Amazon.
Okay,
On
awesome.
Amazon.
I would love
Amazon.
to give it a read.
Excellent.
Okay.
Well, this is a
Out.
fantastic show. Thanks for staying long, everyone. I think this is a fascinating time, and a lot of times innovations come just in the nick of time. I think that's what we have here. We do archive all these webinars for later viewing, so we'll post this to YouTube as well. Thank you so much for all your time and attention, and thanks to the crew. We'll talk to you next time. You've been in the briefing room.